Hey guys, I just have some feedback from your 5 factors summative assignment and the driving forces quiz. I'll try and make this quick and useful, okay? So first of all, from the 5 factors summative, right? Some of you are probably wondering why you lost some points from those written ones, right? A lot of it was because people are not addressing the time question. You were doing a good job of saying, oh, when the temperature is higher, it goes faster. That's a rate thing, though. That's not a time. Fast and slow are rate words. They're not time words, which is why I had put that example in the prep worksheet saying, it takes less time and the rate is higher. Okay, so next time I give you examples of things, make sure you use them. They're there for a reason. Also, describe the example, not the factor. So some of you were describing like the factor and its effects, but not giving me an example of that in action. So an example of an example is in the videos when I was showing the Alka-Seltzer, right, which are effervescent tablets for those of you who did use the same example that I used when I said not to. All right, that's why it looked exactly the same as my videos. All right, but you have to describe an example of it in action. All right, I can see that those general search terms I gave you guys were useful. I saw a lot of stuff about glow sticks, saw a lot about marble chips and hydrochloric acid. Several people found the milk powder video that I did not know existed until Mrs. Beamer showed that to me. And then some of you found it. That was hilarious. All right, so I did see a lot of repeats, so I was glad to see you guys using those general search terms. All right, the video that you watched did not mention surface area or catalyst, and you could have rewatched it. I'm just saying. All right, it did mention the other 3, but it did not mention those 2. Okay. A couple other specific things here. Concentration still can't affect energy or orientation of collisions. So in the video one, a lot of you were saying, oh, they were colliding more often and they were colliding with more energy. There was no evidence in the iodine clock video that they were at different temperatures, right? The other video didn't imply that. Saying that they were colliding with more energy or with a better orientation doesn't really make sense because you're analyzing concentration. You guys did a much better job recognizing that temperature doesn't affect orientation, all right? And the surface area was better than the concentration one also, okay? And then the last thing is that concentration is about the distances between the particles, right? In a solution, you can think of your particles as all mainly accessible, but you just have to get to them, okay? And then the surface area is about the exposure or the accessibility. Some of you had that backwards. All right, for the driving forces quiz, just a note, when I ask for a molecule, writing like Fe is not a molecule, okay? I did accept diamond because you have covalent bonds. You could technically make an argument for a diamond being a molecule, okay? But just writing an element symbol is not quite answering the question, okay? Picking something that's highly reactive when you're asked for a stable molecule is not a great idea. So if you've seen pictures or videos of hydrogen reacting very rapidly and violently with oxygen, then telling me that hydrogen is really stable, not a great idea. All right. Also calcium. You reacted calcium with water in the lab yourselves and a couple of times, I think. And so you've seen that calcium reacts with water. So it's not really a good example of something stable. Also, it's an individual element symbol. All right. And some of the other metals, like if you chose an alkali metal, that was not a good choice. Okay. Those are highly reactive. All right. Pay attention to states of matter. Some of you guys aren't reading the question or you aren't thinking about the state of matter at all. All right. I have people tell me that like iron was a good example of a stable molecule with high entropy, which would mean it's a gas and a molecule. It's neither of those things. Okay. Overall, the rest, the actually analyzing the reactions went pretty well. All right. Every single question that was on there has an example in the notes and practice that goes along with it as well. So just keep in mind, like this is all online. You have all your resources available. So use that summary sheet, use the practice worksheet, help double check things as you're going. All right. We will be finishing that last column in the worksheet, all right, and doing some more with that equilibrium idea moving forward here. Okay, so hopefully feedback helped answer your questions. If you lost points on something, and if you still have an additional question about something in particular, just shoot me an email.